My name is David Carlisle. I'm one of the DE/DP students at University of North Dakota, taking Electrical Engineering 304, Computer-Aided Measurement and Controls. My project was to build and test a Linear Voltage Displacement Transducer, also known as an LVDT. An LVDT is really three coils, one primary coil in the middle, and a secondary coil on the left side in my case, and the right side in this case. And what happens is you put a sinusoidal signal on the primary coil and it generates a signal through magnetic coupling on the two secondary coils. We also use an iron core to increase the coupling between the two coils and the primary coil. The last part of significance is that with the two output coils, the coils are actually wired in reverse polarity. So they basically fight each other. When your coil is perfectly centered, you'll have no output from your two primary coils. Two secondary coils. When your core is on the far left, the left side core will dominate and produce a signal. When you move it from left to right, the right side core will dominate and start producing an output signal. And we can use this output signal to determine the physical position of a machine or an object. And these types of devices are used throughout the industry for that purpose. So I put a VI together to watch what's going on. I start off with a MyDAC assessment providing a sinusoidal output signal to the NI MyDAC board. And then I also have a MyDAC assessment which reads two input signals. I plot these input signals on a waveform graph. I also have outputs for a real matrix and a couple signal outputs that I'll talk about in a little bit. What I don't show on this VI is I did at one point have a writing file capability. Basically, I was writing this matrix to a file, and I used that from my other class, EE314, for that data. But that's kind of a one-shot event, and every time you run it once, it will stop and ask you for a file to save. So you don't have the file writing on this example, but you have the functionality for showing the dynamics. So right now I have the core in the middle of the coil, and as I go from right to left, you'll first of all you notice that a signal starts appearing. The input signal is the white, and the output signal is the red. It'll increase, increase, increase. The point I get some distortion. The distortion is more because of limitations of LabVIEW and the MyDAC equipment. Then I'm going to go from left to right. Notice I'm currently in phase. I'm going to transition to a 0 point, and then I'm going to go out of phase as I go past 0 from left to right. I can use this phase transition to decide what side of 0 I'm on, and that's what I do with, you can see a sub-VI in my VI. This sub-VI will do two things. First of all, it takes the entire matrix, finds the maximum, and also finds whether or not the maximum is actually in phase or out of phase, and then gives me an output based on position. With that output, I can use just an indicator, and I also added a slider bar to show that the position is going to be 0 to negative 0.6, almost through positive 0.6. Right now I'm almost all the way to the left. Looks like that's about as far as I'm going to go. And as I go from left to right, the slider will change. In addition, the core position value is changing. On the far right, going right to left. It really was a fun project. I did wind my own LVDT coil, which was a little more difficult than I thought it was going to be. If I was going to do it again, I'd just use 3 spools right up next to each other. But had a lot of fun, and I was glad it worked out, and I was able to do a lot of really neat things with with the National Instruments MyDAC systems, and the inputs, outputs, and the class, and what I've learned in this class. Again, this is David Carlisle with University of North Dakota, DEDP student, EE 304. Thank you very much.